Hey, hello everyone. So today's problem of the day is count vowel string in range. So what we have right now is that we have given a zero indexed array of string words, okay, and a 2D array of integers queries. So it is basically of a simple 1D array integer with just two more values, which includes the left and right range. Okay, so each query will be query I contain LRI, RI. They are both inclusive, which shows from what initial index to final index we need to check out the number of strings in the given words string array that have the the words which are starts with vowel and also ends with the vowel. So how are we going to do this? So the brute force that's coming in my mind is that 0 to 2, we can go with the every query 0 to 2, then we will go with 0 to 2 index and check out if they how many of the words starts with the vowel and ends with the vowel. Then again if we go with 1 to 4, then 1 to 4. So the issue that is in this approach is it might contain of n square. Why of n square time complexity that's coming in my mind is, let's say there are n queries and each query contains 0 to last element. So for every single query we go and check. So it will kind of like we are doing two uh, two iterations, uh, two times for us for a single thing. So what we are going to do is we somehow store the we will store pre we will pre-calculate in the prefix sum the number of words from 0 to n that starts with vowel and ends with vowel. Okay, so let's start with this. Let's have a map, unordered map, let's say map which will contain character and int and mp. Okay, this will contain mp of a, mp of a plus plus e, I, and o and u. Okay, so these are our vowels. So let's make a vector prefix which will calculate how many total words are there till that index having starting and ending with some vowel. Okay, so let's say it's prefix. Okay, and its size will be equal to w words dot size. Okay, now let's start with words dot size and I plus plus. Okay, so our first string will be string m, which will be our words I. Okay, so this is our first string. We will check if this string contains if this string is having starting and ending with a vowel or no. So let's say we will create another function that will be a bool function that checks, in which will give a string s, and it will just check string s with unordered map m. Okay, and hmm, so we'll just check if mp dot find s0 not equals to mp dot and mp dot find s s dot length minus 1 not equals to mp dot add. Okay, if these things are true, then we will be return true, otherwise return false. Okay, and if we have returned true and count let's say equals to 0, then if check temp comma mp, then count plus plus, else कुछ नहीं, and pi equals to count. Okay, so that's how we get our prefix sum of every single numbers, how much we have or how much we don't have, the words that for that particular index. Okay, uh, got it. Now what we will do is we will start with the our queries. Okay, and we require an vector of int answer जिसका size होगा queries के equal, we are at queries dot size. Okay, and for int I equals to 0, I less than dot size and I plus plus. So what we get is we start with the queries. So our first query, so int L will be queries k first, similarly R will be queries k second. Okay, we got both. Now what we will do is if L equals 0, then we will just directly answer I equals P of L R. Okay, otherwise answer of I equals to P of R minus P of L minus 1, and then we just return. So let's check out if we are doing it right or wrong. Submit. Okay, 95 days current state. Okay, so what is the time and space complexity that we have to find out? Okay, time and space complexity. Initially, we define NP with a constant space of 5 characters, so I guess it will not count. If we insert anything inside a map, uh, unordered map, insert time complexity, then it is of 1. In the worst case, complexity average is of 1 because of 1, and worst case is of n due to the hash collisions. Okay, let's say it's of 1, and we define a vector, we then int count, then okay, we just go through the size of words, so it will be big of whatever the size. Words length is 10 raised to the power 5 and queries length is 10, so it will be 10 raised to the power 5. Worst is O n. So time complexity is big of n, and space complexity P is big O, and because we are prerequisite, ठीक है, big O. So I guess this is the space and time complexity. Let's check out much better approaches. You also have prefix 0, prefix dot reserve or dot size plus 1, count C, start with a prefix, then answer that dot reserve queries dot size, then he just push back this and return that. Okay, so nothing so fast. Here vector, then this is our is vowel vector. Okay, he doesn't define, he just has simple is or our request. Okay, and he just increase it by one prefix. Okay, rather than using the map, we can just simply have if condition like this. So we don't haven't required any insertion or any kind of such thing. Okay, got it. Yeah. So I guess we are pretty good here. Thank you guys. We'll meet again. Bye bye.